5 o'clock. Let us start. Today I need to leave at 6 o'clock, so I'll conduct a class of 50 minutes plus 10 minutes for questions and answers. Okay. As we discussed in last class, these are the various topics of first module. And we covered first 3 topics in last class. Structure of artificial neural network was covered. Basic building blocks of neural network, which are neurons only. So they were also covered. Learning representations from data. So to learn representations from data, we discussed 3 types of learning techniques: supervised learning, unsupervised learning, and we also discuss reinforcement learning. Okay, so today I shall discuss shallow network and single and multi-layer perceptron. So let us start with like a basic artificial neural network today after discussing shallow network. So now I shall jump to shallow network topic. Okay, we discussed all this. Okay, so let us discuss shallow network first. What is shallow network? Okay, now when we hear the term artificial neural network, usually we feel that it consists of many and many hidden layers. But actually, there is a type of neural network with a few number of hidden layers, and that is called a shallow neural network. The shallow neural network has only one, or you can say just a few hidden layers between the input and output layers. As you can see in this figure, there is one input layer, one output layer, and in between there is only one hidden layer. So this figure shows a shallow neural network with one hidden layer, one input layer, and one output layer. As we discussed previously, we always have one input layer, we always have one output layer, but we can have numerous hidden layers between input and output layer. So what is shallow neural network? Shallow neural network in which we have only one hidden layer or just a few hidden layers. Now, input layer receives the data as we discussed earlier. These are the arrows to feed input to this neurons in input layer. Hidden layers, they process this data, and final layer produces the output. So the shallow neural networks, these are, you can see that very simple in architecture, and they can be trained more easily because they are simple in architecture. They have greater computational efficiency than deep neural network, of course, because in deep neural network, number of neurons are many more. And hence, as we discussed earlier, each neuron is responsible for mathematical operation. So if there are more number of neurons, then more mathematical computation is involved in neural network. And that's why we say that this shallow network, they are simple in architecture and they are computationally efficient because compared to deep neural network, they involve less computation. I hope this is clear. Which may, like deep neural network, as we know, it may have thousands of hidden units, that is thousands of neurons in dozens of layers because they are deep in architecture. So more hidden layers are there. In each hidden layers, several neurons can be there. So you can, like we know that the number of neurons, the computation involved in artificial neural network, it is proportionate to the number of layers and number of neurons in layers. Fine. So these are very simple artificial neural networks. These shallow networks are typically used for simple tasks such as linear regression, binary classification, low dimensional feature extraction. So for simpler tasks, this shallow neural networks are used. Network, as I told you, that these are the networks with very few hidden layers. So sometimes, however, in place of one, if neural network has 2 to 3 hidden layers, then also sometimes we call them shallow network with each with a small number of hidden units having simple connections in straightforward manner. So they are also sometimes called shallow neural network. I tell you the fact, earlier we were using only artificial neural networks with 2 to 3 hidden layers. We never thought that in future we will have deep neural network. When deep neural network were invented, that time they were also not much deep in architecture. But today we have deep neural networks having more than 150 hidden layers. So today we are saying that if artificial neural network has one or two or like hidden one or two hidden layers, then we call them shallow network. But in future, after 1 decade, if we call artificial neural network having 10 hidden layers as shallow network, then that there should not be surprise, because that we cannot imagine the deep architecture of neural networks in future after 1 decade, because before 1 decade we never thought that we will have neural networks with 150 hidden layers or more than 150 hidden layers. Similarly, after 10 years, after 1 decade, like we may have neural networks with deep, much more deep architecture. Okay, now there are some, let me give you some examples of shallow neural network. The simple shallow neural networks are logistic regression, support vector machine, random forest, then cluster analysis. We can consider all this as shallow neural networks. So if you have learned machine learning, then you must be knowing a support vector machine, and you must be knowing random forest too and logistic regression too. So all this can be considered as shallow neural networks. Okay, now after understanding this shallow network, now let us discuss the differences between shallow neural network and deep neural network, or in simple terms, we can say that differences between neural network and deep neural network. So there are some basic differences, like we know that shallow network could perform as good as deeper ones, but it does not always. They usually do not perform good for complex tasks, and that's why deep neural networks were invented. So shallow network would need more neurons than the shallow network, they have less number of neurons than deep neural networks. It is but obvious because they have less hidden layers and they have less number of neurons. Shallow network is more difficult to train with our current algorithms. So that's why like deep neural networks are required. So there are some disadvantages of shallow network too, because of which we need deep neural networks, like they are more difficult to train. Then they cannot handle complex tasks. Maybe shallow architecture does not fit to the kind of problems we usually trying to solve, like object recognition, or there may be some other reasons too. So that's why like deep neural networks were invented. Differences are like this. Differences are like several types of neural networks are available. And as I told you that major difference between them lie in three major things: their working principle, their scheme of actions, and their application areas. So if we talk about the neural networks, they can be recurrent or they can be feed forward. They can be recurrent or they can be feed forward. Feed forward neural networks do not have any loops in their graph. We are going to discuss that feed forward neural networks in detail after today, these two topics like shallow network and perceptron. We will discuss this feed forward neural network. So neural networks, they can be recurrent or feed forward, and feed forward neural networks, they do not have any loops in their graph and they can be organized in layers. Now, if there are many layers, then we say that the network is. Now, question arises here that how many layers does a network have to have in order to qualify itself as a deep neural network, right? There is no standard answer to this question. There is no definite answer. It's a bit like asking how many grains make a heap, like there is no standard answer. Usually neural network with one to two hidden layers, they are called normal neural networks. They are called shallow neural networks. And if neural network has hidden layers more than two, then they can be considered as deep neural network, which can be used to train complex data, and they can be used to predict the output, training them with complex data. Now, in contrast, a network with only a single or yes, we have discussed that single or two, then it is called shallow neural network. The neural network is simple. Shallow neural network is simple and it is not creative system. Okay, understand this. It's not a creative system. But deep neural network is much more complicated than the neural network. It can recognize voice commands. See, we have like recurrent neural network, right? With which we can process time series data. So this like simple shallow neural network, they are not able to recognize voice commands. But if we have deep neural network, it can recognize voice commands, it can recognize sound and graphics, it can do an expert review, and it can also perform a lot of other actions that require prediction, creative thinking, and analytics. But shallow neural network cannot does all these activities. Other than deep neural network, only the human brain has capabilities to do all these tasks. Which tasks? Recognizing voice commands, recognizing sound and graphics, right? Recognizing like creative thinking. All these abilities only human brain has. But deep neural networks, they also have these abilities. So this is how they differ from shallow neural network. The next difference is neural network can get one result at a time, like word, an action, a number, or one solution. So this is how shallow neural network performs, that it can get one result at a time. Fine. But deep neural network, they solve problem more globally, and they can draw conclusions or predictions depending on the information supply, and they can predict like more complex information correctly. These components are not brought to the system directly, and this is how the deep neural network works. The complex components, like even if they are not brought to the system directly, it can perform this task, and deep neural network works here. So these are some basic differences between shallow neural network and deep neural network. Okay, now after this shallow neural network, let us discuss single layer and multi-layer perceptron. Let us see what is perceptron, what is single layer perceptron, and what is multi-layer perceptron. As you can notice here, as it is written here, inspired by the biological functioning of a neuron, an American scientist, Frank Rosenblatt, came up with the concept of perceptron in 1957. So this is not a new concept. This concept was introduced in 1957. Here you can see the simple perceptron. Perceptron is basically a binary classifier. Okay, binary classifier. Perceptron consists of three main parts. As you can see in this figure, I'll tell you which three parts. Input nodes, or you can say input layer, that is the first part. This is input layer, and three inputs are there, three input nodes are there, X, Y, Z. Okay, so input nodes or input layer, that is one component, one part. This layer takes the initial data into the system for further processing, and each input node is associated with a numerical value, and it can take any real value, numerical value, any real numeric value. Fine. These are the weights, and then you will have bias here. So weight parameters, they represent the strength of the connection between units. These are the units. Okay, I tell you, neurons are also called units. So these words are used interchangeably, neurons, units. So which are the units? Here you can see that these are the three units in input layer. Here there is one more unit. Okay, so you can, what is unit? Like, okay, neurons are called units. And what is weight? Weight parameter represents the strength of the connection between input unit and this unit. Higher is the weight, stronger is the influence of the associated input neuron. If this weight is higher, okay, higher is the weight. Please understand this. This is fundamental of working of neural network. Higher is the weight, stronger is the influence of the associated input neuron to decide the output. And that's why you can see that here there are 0 and 1. So this is higher. If this is higher, what does it mean? The influence of associated input would be higher in prediction. So influence of X, or you can, influence of X would be higher in predicting the output. Okay, now, as I told you, the second component consists of weight and bias. Now, what is bias? Bias plays the same as the intercept in linear equation. So that's why I was telling you that if you have learned fundamentals of machine learning, then it would have been easy for you to understand this, because there we learn what is intercept in linear equation. So bias plays the same role as the intercept in the linear equation. However, I'll discuss again what is bias. The third component of perceptron is activation function. I repeat, three components are there. First component is input layer, or you can say input nodes. Second component is weights and bias. Third component is activation function. The activation function determines whether neuron will fire or not. Where activation function determines, here is the activation function which determines whether neuron will fire or not. At its simplest, the activation function is a step function, but based on the scenario, different activation functions can be used. There are several activation functions, and it is one of the topics in first module. So I'll discuss various activation functions also. So we have different activation functions, but the simplest one is step function. Okay, so these are like different components of perceptron. Input nodes, weights and bias, and activation function. Now XYZ, these are inputs, W0, W1 and W2, they are weights. Okay, as you can see. Okay, now how it is processed, let me explain you how this is processed. Now this is expanded, you can see that. Now we can have, not necessary that always we should have 3 inputs, we can have n inputs here. So this is my input layer which represents n inputs. X1 to Xn are the inputs. If X1 to Xn are the inputs, then I should have W1 to Wn weight values. So these are W1 to Wn weight values. Now the inputs, this input values X1 to Xn, they are multiplied with weights W1 to Wn, and they are passed in this neuron. This is the neuron. That is perceptron activation function, which is in this case will help you to get the outcome. Okay, so this X1 into W1 plus X2 into W2 plus X3 into W3 and so on. So this can be represented by sigma Wi into Xi. Okay, then bias is added. Again, I'll discuss bias. Don't worry, bias is added after that. Okay, so bias gets added, and after that activation function. Let me tell you why do we use activation function. Activation function determines whether neuron will fire or not. Okay, this is step 2. This is step 1 where these are multiplied and bias is added. That is step 1, and step 2 where we use activation function. So this is the activation function. Here you can see that. Now this sum which we are doing here, this sum gives an approximate representation of the inputs based on their importance. I repeat, and then I'll explain you. This sum, it gives an approximate representation of the inputs based on their importance. How importance is decided? If weight value is higher, its importance is higher. If weight value is lower, its importance is lower. So you can see that this is weighted sum. This is weighted sum. X1 into W1, X2 into W2, X3 into W3, and so on. So they are added. Okay, so the sum gives an approximate representation of input data based on their importance. Additionally, bias term B, it is added, and bias serves as another model parameter in addition to weights that can be turned to improve the model's performance. Bias is tuned to improve the model's performance. After that, in second step, activation function, again bias will be discussed. So don't worry, I'm gradually discussing the fundamentals of neural networks so that you can thoroughly understand it. So though I introduced some of these terms in previous class, again when we are discussing the single layer perceptron, I'm repeating these terms, that what is weight, what are input nodes, what is bias. Again, they will be discussed, right? So don't worry. So bias is like, you can see that the bias serves as another model parameter that can be tuned to improve the model's performance. In second step, this is step 2. In second step, activation function f is applied over this sum, okay, to obtain this output. Which output? Y is equal to f of sigma Wixi plus B. So this is like this entire term, it represents my output. Now, depending upon the scenario and the activation function used, the output is either 0 or 1, like binary, 0 or 1, right? Or it may be continuous value. If it is binary classification, then it would be 0 or 1. If it is not binary, it may be continuous value. If it is not classification problem, if it is, for example, prediction problem, then it would be continuous value. Now, often both these steps are represented as a single step in multi-layer perceptron. So this is one difference between single layer perceptron and multi-layer perceptron. In single layer perceptron, both these steps are represented differently, separately. But if it is multi-layer perceptron, the steps are represented as a single step. And here, like they are shown as two different steps. Okay. Okay, now, okay, fine. Before that, let me discuss. Fine. Activation function. The simplest activation function is unit step activation function. Unit step activation function, which was originally used by this mathematician of this single perceptron. And this function, like it outputs between 0 and 1. And another one is hyperbolic, like tanh, hyperbolic tangent function. There are, in fact, several. ReLU is also there and all. Let us discuss them after these topics. Okay. Now here you can see that this can be used as this can be used as binary classification, but remember that this is used for linear data. Single layer perceptron is used for linear data. What do you mean by linear data? The two types of data in your data set, they can be partitioned by a plane, by a single line. So here you can see that you may be given a set of data which includes two types of data, say green circles and blue circles. Now, if you can train neural networks such that it differentiates these two types of data by the single line, then you can say that it is linear data, and it can be classified in two classes via a single line. And here you can see that this figure represents non-linear data. Like this is not line by which they are separated. This is a circle. Second, though, this is also binary classification problem. Binary classification means you have two classes to segregate your data. So here we have two classes in both the figures. Green circles, they represent one class, and blue circles, they represent another class. But here, both the classes, they are separated by a single line. So we can say that this is linear data, linearly separable data. And here they are not separated by lines. Circle is there to separate them. So this is non-linear. This data is non-linear in nature. Fine. So we can't use single layer perceptron for non-linear data. We can use single layer perceptron for linear data. So activation function, it works like this. Activation function, as I told you, it is unit step activation function. So it's a kind of threshold we use here. Unit step matlab threshold activation function, which was originally proposed by the mathematician of the single layer perceptron only. And you can see that this is a threshold, right? Fine. So if if input is greater than 0, then class is 0. If it is okay, this is like a mistake. I'll discuss with in next example. Okay. Now let us understand the single layer perceptron with example. Fine. So this would be more clear now with example. Okay. Let us start with a classification problem. Assume that our aim is to predict whether the loan should be approved to a customer or not. Let us assume that our aim is to predict whether the loan should be given loan should be approved to a customer or not, depending on the salary of that customer. Okay, or depending on the salary of a person. So in order to do that, we will need to build a model that takes the salary of the person or not. Okay. So answer would be yes or no, right? And your salary. If salary is low, answer would be no. If salary is high, loan can be approved. The answer would be yes, right? So this is how we can represent problem. Fine. So if we want to create a model, how the model can be represented? The model would be like this. You can see that model would be like this. The salary would be input, and here some processing will be done, and then answer would be yes or no. Answer would be yes or no. So this is binary classification problem, right? Now suppose your bank wants to reduce the risk of loan default, and hence suppose bank has decided to roll out loans to only those people or only those customers who have a monthly salary of 50,000 and above. Okay, 50,000 and above. So then the same problem can be represented like this. Please pay attention. Okay, now the same problem is modified. Bank has decided to give loan only to those people who have salary greater than 50,000 per month. X-axis represents salary. Okay, so here we have 50,000. So this is the threshold we can say. If salary is below 50,000, loan should not be approved. And if salary is above 50,000, loan should be approved. So this is the criteria. Fine. Okay, so which are the tasks we want to model here with this neural network? If we discuss on that, okay, then this model takes input to this model. Okay, now this model takes input, it processes that, it checks whether it is greater than 50 or not, and accordingly it gives output yes or no. So this is kind of neural network. Okay, now coming back to our example, let us have a look at each of this task starting from the input. We have a single input, which is salary. Okay, we have single input, so our only one x we don't have x1 to xn, we have only one x, a single input, and that is salary. But in general, in this neural network terminology, they are also called features. They're also called features. So we can have one feature or we can have multiple features. Okay, just like one feature like salary. Okay, but we can have multiple features. Multiple features like applicant salary, his her father's salary, spouse salary. That can also be that can also help us to decide whether loan should be approved or not. The salary can definitely considered. Okay. And our neurons will take all these features as input in order to make decisions. If we want to consider all these features, instead of only that one person's salary, if we want to consider father's salary also, if we want to consider spouse salary also. So now we have we have three input data. We don't have only one now, we have three. So this is to say that the neuron will have multiple inputs now. And this is similar to the multiple dendrites that we saw in a biological neuron, right? Multiple dendrites. So then the network would be like this. Applicant salary, father's salary, and spouse salary. So we have three input parameters, x1, x2, and x3. Now that there are multiple salary features about the person, we will take all of them into consideration as they represent the total income of the family, total income through total household income, right? So we will take all of them into consideration. Now we can sum them up and we can check if the total income of the household crosses the threshold or not. Let us assume that still the threshold is 50,000. Though we are considering the house income, because the threshold 50,000 is to approve the loan, whether loan should be approved or not. So maybe that person salary is not above 50,000, but when we sum up the family income, then it is greater than 50,000. Okay, so this is greater than, and so total income would be applicant salary. Like this would be the total income, x1 plus x2 plus x3. We can sum up that and we can check whether it is greater than threshold or not. In our case, it is 50,000. Now we need to compare this with threshold, and then we can check if the sum crosses the threshold. So it would be like this. If you bring this threshold to the left side of the equation, it will become something like this, right? Threshold I have taken on the left side. So this should be greater than 0. And if we represent this whole quantity, which is minus threshold with a new term bias, the updated equation would be, now what I'll do, I'll represent this minus threshold as bias. I'll represent minus threshold as bias. So this is my updated equation. This is my updated equation. Look at this. This was the original equation. X1 plus X2 plus X3, they should be greater than 50,000 in our case. Right now, I'm taking this threshold on the left side. So this is greater than 0. And now minus threshold is replaced by bias. So this equation has been like this. Right? This will have the sum of 4 quantities now, X1, X2, X3. And bias is actually minus threshold. The 4 quantities, the 4 parameters we are summing up. Okay. So we will say that output should be 1 when this equation is true, and output should be 0 in all other cases. Zero in all other cases, and these two equations can be represented in the form of a function like this. If x1 plus x2 plus x3 plus bias is greater than 0, then output should be 1. And if this is lesser or equal to 0, then output should be 0. So this binary classification means 1 or 0, whether loan should be approved or not, yes or no, right? So this is our equation x1. These are input quantities and this is bias. If this whole equation is value greater than 0, then output should be 1. If it is less or equal to 0, then output should be 0. So you can represent it like this. Or this entire network, this network can be represented by this formula. Z is our Z is equal to, this is like Z is equal to, here is the Z. Z is equal to x1 plus x2 plus x3 plus bias. And it would be 1 if this is greater than 0, would be 0 otherwise. Fine. So this is our perceptron model. This is our perceptron model, right? So this is called single layer perceptron, only one neuron. There is only one neuron, right? Yeah. So questions after some time. Fine. So okay. So this is a like simple perceptron we have seen. Now here step function is there or not? Okay. I forgot to include that figure here. Anyway, so here we have some of the 3 features and bias represented at Z, and we want our output to be 1 if the Z is greater than 0, otherwise 0. So we can use here step function. And this is the like step function, just we saw it. Okay, so we can use here step function, right? But as we discussed, there are several activation function, and step function is simple activation function. So when we use the step function as the activation function for a neuron, it is called perceptron. When we use step function for a neuron, when we use step function as the activation function for a neuron, it is called perceptron, right? Okay. Now let's see what are the drawbacks of this single layer perceptron. It cannot be used for contemporary complex problems to solve modern problems because they are very simple. Moreover, the output of perceptron can only be binary numbers, 0 or 1, due to the hard limit transfer functions. And this perceptron can only be used to classify the linearly separable data with only one neuron. It can't be applied to nonlinear data. More, for example, the Boolean function XOR, the XOR gate. The XOR gate returns 1 if the inputs are different, right? So this is, we can say that XOR gate is not a linearly separable. It is non-linear. And we can't use perceptron. It cannot be a computer, it cannot be computed by a single layer perceptron, this XOR function. It cannot be computed by single layer perceptron. In short, we cannot use perceptron for non-linear data. It is applicable only to linearly separable data. So that is the limitation of this single layer perceptron. So multi-layer perceptron was invented, and let us discuss multi-layer perceptron now. Okay. Now, before we discuss multi-layer perceptron, let me take a few questions. I'll take more questions at the end of this class. Okay, those who have questions, they may ask if they have any questions related to single layer perceptron. Yes, Soham.
Hello, ma'am. Am I audible?
Soham, you may ask.
Hello, ma'am. Am I audible? Hello,
Okay,
ma'am.
next, who is next? They can ask. Dhruvik, you may ask.
Hello, ma'am. Am I audible?
Yeah, you are audible.
हाँ मैम अब आ रहा है आवाज हेलो
Hello. Yeah, I'm getting your voice.
हाँ मैम आपने कहा था कि एक जो परसेप्ट्रॉन होता है वो एक्टिवेशन फंक्शन के लिए एक स्टेप फंक्शन को यूज करता है तो उसका आउटपुट है वो भी बाइनरी होता है 0 या तो 1 तो वो भी
Correct.
एक तरह का स्टेप फंक्शन ही हुआ ना तो
We
फिर
can
हम
have different
आपने जो
activation
लीनियर फंक्शन पहले बताया
functions. So to get binary output, we use step function as the activation function in perceptron.
हाँ तो हमें आउटपुट में भी कोई स्टेप फंक्शन ही मिलेगा ना
आउटपुट में हमें 0 या 1 मिलेगा.
हाँ तो वो भी एक टाइप का स्टेप फंक्शन हुआ ना कि हाँ तो अगर तो आपने जो पहले वो लीनियर वाला जो बताया था ग्राफ की जो दो अलग अलग टाइप के डेटा को सेपरेट कर रहा था वो लीनियर था लेकिन वो मतलब बाइनरी जैसा तो नहीं लग रहा था स्टेप फंक्शन जैसा
बाइनरी मतलब दो classes of the sun, and we want to diagnose whether patient is suffering from disease or not. Just we want yes or no.
Yes.
Right? So suppose if I have a CT scan of 10 patients, they will be classified in two groups. Those one group, all patients having that disease. Second group, all patients not having that disease. So there are two groups. So in like data, I have data of 10 patients which are classified in two groups, having disease and having, it's a classification, right?
Okay.
So answer will be yes or no only, but they are classified. So that graph was representing that green circles, ye jo graph hai. So suppose we have a data, we have data. So data is classified in two classes: suffering from disease, not suffering from disease. Okay. Who has who next? Who is next? Dhruvik, yeah, you may ask. Yeah, Dhruvik.
मैम इस 27 स्लाइड नंबर ए और बी में जो सेपरेट है ग्रीन टू डॉट वो बी में नॉन लीनियर है वो सर्कल से सेपरेट है तो बी भी लीनियर नहीं हो सकता
B, it's not linear. Linear means when you can separate two classes by a line. Here we are not separate. Here we have two classes. Okay, this is binary problem only. Both these graphs, they represent binary problem. Binary problem means you want to classify data into two classes. I hope this is clear. Binary problem means you want to classify data into two class, second blue color. Here also we are classifying in two classes, green color and blue color. But these two classes are separable by a linear line. While these two classes are not separable by a linear line, you can see that if I draw a line anywhere here, like can you have a data of one class on one side and data of other class on the other side? No, you cannot have. So this is non-linear data and this is linear data.
Okay, thank you.
Yeah. Yeah, Hansi.
Ma'am, in
Hansi.
hello,
Ah.
ma'am.
Yeah, I can hear you.
Ma'am, in the above example of that neuron that decides the approval of loan, in that example, what are weights?
Weights we have yet not discussed. We randomly set initially. I'll discuss this part again. But weights we set randomly initially, and as we go through several iterations, this weights get updated. So that part I'll discuss again in depth, that how weights are updated. Okay. So initially we set randomly between 0 to 1.
Okay, ma'am. Thank you.
Yeah. Okay. So now let's start multi-layer perceptron. And then again, I'll take your questions at the end. Okay. Sorry. Find multi-layer perceptron. Yeah, so drawback we have seen. So multi-layer perceptron was developed to tackle the limitation of single-layer perceptron. And this multi-layer perceptron is a neural network where the mapping between inputs and output is non-linear. Okay, please remember what is the limitation of single-layer perceptron? It cannot handle non-linear data. So to overcome that limitation, multi-layer perceptron was proposed, and this is a neural network where the mapping between input and output is non-linear. This multi-layer perceptron has input and output layers and one or more hidden layers. One or more hidden layers with many neurons stacked together. In perceptron, the neuron must have an activation function that imposes a threshold that just we discussed, right? In a single layer perceptron, a neuron must have an activation function that imposes a threshold. Multi-layer perceptron falls under the category while multi-layer perceptron falls under the category of feed-forward algorithm because inputs are combined with the initial weights in a weighted sum and subjected to the activation function just like the perceptron. But the difference is that each linear combination is propagated to the next layer. Each linear combination is propagated to the next layer. Each layer is feeding the next one with the result of that combination, their internal representation of the data. And this goes all the way through the hidden layers to the output layer, right? From input layer to hidden layer to output layer. But it has more to do. Though like it seems very simple, no, it has more to do. If algorithm only computed the weighted sums in each neuron, propagated results to the output layer and stopped there, it wouldn't be able to learn the weights that minimizes the cost function. Like now this is a new term again, cost function. I'll discuss it too later. Now, if algorithm only computed one iteration, there would be no actual learning, right? We discussed in previous class that we do not feed this data only once to neural network. We feed again and again because we know that when we feed that data to again and again and neural network is exposed to that data repeatedly, then learning increases. And if learning increases, then only it be able to produce correct outputs. Right? So learning is not sufficient via only one iteration. So this is where back propagation comes into picture. Now, what is back propagation here? Okay, back propagation is the learning mechanism that allows this multi-layer perceptron to iteratively adjust the weights. It allows backpropagation allows this multi-layer perceptron to iteratively adjust the weights in the network with the goal of minimizing the cost function. Okay, so what we do here actually, I don't know whether I have included that figure or not. I think I have not included. Okay, we compute, let me check. No, I have, but error is there. Okay, that figure is not included. What we do here, we compute error here that this is fed to neurons of hidden layer. This output is fed here. It is fed to activation function and we get prediction from this network. Now this predicted output is compared with the actual output. Predicted output is compared with the actual output and the difference is known as error. So we compute error usually like this is one of the, there are several error measures also. This is one of them, mean squared error. So we compute error here that how predicted output differs from the desired output, actual output. If that error is more, if that value is higher, then we adjust weights in next iteration. We adjust weights in next iteration so that this error gets minimized. Our ultimate objective is to minimize the error so that predicted output should be similar to the actual. Okay, so to make it like to make the prediction similar to actual, ideally this error should be zero. Ideally error should be zero, right? So if I compute the difference between predicted output and actual output, the difference should be zero. That means zero error. If zero error, then you can freeze the training of this network because like weights have converged. But this does not happen only in one iteration. Initially, we set these weight values randomly and then we go via multiple iterations. So backpropagation is a learning mechanism that allows the multi-layer perceptron to iteratively adjust the weights in the network with the goal of minimizing the error. That is called cost function. Now, there is one hard requirement for backpropagation to work properly, and the function that combines inputs and weights in a neuron, the instance, the weighted sum, and the threshold function. For instance, ReLU. Now, ReLU is another like activation function, and that must be differentiable. So this function must have a bounded derivative because gradient descent is typically the optimization function used by multi-layer perceptron. So this is the separate topic in your first unit. So I'm going to discuss this feed-forward network and backpropagation with gradient descent again because they are separate topics in your unit, but they are used, this backpropagation is used by this multi-layer perceptron also. Fine, so we are discussing it here also. Okay. So now in each iteration, what we do, functions must have bounded derivative that we discussed. Now in each iteration matlab from start to end. In each iteration, after the weighted sums are forwarded through all layers, this weighted sums, they are forwarded through all layers. Okay, the gradient of the mean squared error. The gradient of the mean squared error is computed across all input and output pairs, and then to propagate it back, here you can see the back propagation. To propagate it back, the weights of the first hidden layer are updated with the value of the gradient. So there we use gradient. The weights are updated. Initially, we set some value for this weight parameter. Now they are updated with the value of the gradient. That is how the weights are propagated back to the starting point of the neural network. So here you can understand this is the gradient current iteration, and here you can see that this is bias, this is error, okay, and this is learning rate. Now learning rate is also another parameter which is used when we train this neural networks. All these are called hyperparameters, which I am going to discuss again separately, that which are the hyperparameters you need to tune when you train artificial neural network. All those hyperparameters are very important to understand and to set appropriately, so that like to tune appropriately during your training, so that your network can converge and learn to predict for future new data or future new samples. Okay, so this process keeps going until, okay, this process keeps going until gradient for each input output pair has converged, meaning that the newly computed gradient has not changed more than the specified convergence threshold compared to the previous iteration. So this is how the training goes on in multiple iterations, and neural network gets trained. And finally, once it converges, like we use that trained model to predict output for the future new data. Because the training is given using the past data. Once it is trained using past data, it will be used for new data in future to predict the actual output. So this is how like a single perceptron and multi-layer perceptron, they work. Okay, but as I have told you, I'm going to discuss these two topics which are separately mentioned in your module. You can see that feed-forward neural network, backpropagation and stochastic gradient descent, different activation functions and loss functions. And along with this, though it is not mentioned in this module, hyperparameters to train neural network will be discussed. So in next class, we will discuss feed-forward neural network, backpropagation, and different activation and loss functions. I think I'll be able to discuss all these things together, or probably in next two classes. So 1 or 2 classes are required to complete this module 1. Okay, fine. So this is about the single layer perceptron and multi-layer perceptron. It's almost 5:50, so I would like to take your questions now in next 10 minutes. Yeah, Soham, please ask.
હેલો મેમ, am I audible?
Yes, Soham, please let me know your question.
हाँ मैम, आपने जो MSC दिखाया मीन स्क्वायर्ड एरर, क्या उससे आपका मतलब ये है कि हम जो एक्सपेक्टेड आउटपुट है और हमारा एक्चुअल आउटपुट आया है उनका हम सब्सट्रैक्ट करेंगे, फिर उसको स्क्वायर करेंगे?
Yes, you are right.
और फिर ग्रेडियंट जो है वो मुझे मतलब एग्जैक्टली हमें आया था, ग्रेडियंट क्या है वो मैं पढ़ने में आया, लेकिन वो थोड़ा सा क्या
Yeah, discuss it again because next class में वही टॉपिक चलने वाला है, back propagation with stochastic gradient.
ओके ओके ओके
हाँ, yeah, Rutul, let me know your question, please.
Hello,
Rutul,
ma'am.
Yeah.
My doubt was a little bit, but in shallow neural network, that if we increase the computation power of neurons in deep neural network, then is it possible that a deep neural network is converted into shallow one?
If we increase, sorry, please, can you repeat your question?
If we increase the computation power of neurons in a deep neural network, then is it possible that network is converted into shallow neural network by reducing the hidden layers?
I think this question is not much valid. Like you are saying that you want to increase the computation power in deep neural network, right? Am I right? Did I understand correctly? Hello? Hello?
Yes, ma'am.
Yeah. Can you hear me, Rutul?
Yes, ma'am.
Yeah. So you want to increase the computation power of neurons in deep neural network. You are increasing computation power, but it is shallow and deep neural network. They do not differ with respect to computation power. Computation, each neuron performs a mathematical task. In deep neural network, we have many hidden layers and we have many neurons. While in shallow neural network, we have usually one hidden layer and a small number of neurons in that one hidden layer. So how you want to convert that deep neural network into shallow, increasing the computation power? I didn't understand that.
I
Or
mean to say
if-
that is it necessary that each neuron has a fixed amount of computation? Like it can perform this much amount of computation, or is it something like that?
what neuron does, that we have already discussed. I think it's not clear to you what neuron does. What neuron does, what have you understood? What it does, neuron. Here we have seen what it does. It
Neuron
simply
takes
has,
the input.
yeah, what it does, but computation, how will you increase computation? What exactly it does? If you have learned here, what exactly it does? See what neuron does. It does summation and then it adds
Uh,
bias.
yes.
So here, how you will increase this computation power? It's a weighted sum only, right? So
Yes.
if you want to create a network with good, efficient neural network, then you should have some more number of hidden layers, some more number of neurons. Architecture is comparatively like this may be there may be simple architecture for neural network. There may be a bit complex architecture. So if it is simple, then learning would be simple.
Okay,
It's
ma'am.
very simple. Every one of us has different learning rate, right? Every one
Yes.
of us has different learning rate. So it's like a simple neural network, they can't learn complex tasks. They cannot learn for automating complex tasks. Fine?
Okay, ma'am.
Okay.
Thank you.
Yeah. Who is next then? हाँ, yeah, Soham.
मैम क्या आप थोड़ा सा मतलब एक्सरसाइज या ऐसा कुछ प्रोवाइड कर सकते हैं इस मतलब लीनियर अलजेब्रा में, मतलब जो आप पर्टिकुलर टॉपिक आज ना आप आज ना नेक्स्ट लेक्चर्स में और आज आपने जो पढ़ा है उसमें से थोड़ा सा जो लीनियर अलजेब्रा है उसकी आप एक्सरसाइज मतलब थोड़ी सी प्रोवाइड कर सकते हैं, या तो फिर वही लिंक वगैरह।
Link to I have not immediately I cannot search and provide now link because as I told you multiple sources are there. And exercise matlab I can give you assignment like this that you can there are if you want to learn mathematics for this neural network, then on Coursera and even on leadingindia.ai, introductory tutorial, introductory.
अरे नहीं
Yeah.
मैम, एक कोर्स पूरा का पूरा लेने में तो बहुत ही टाइम लग जाता है मतलब इसमें जितना मुझे पूरा मतलब मैथमेटिक्स नहीं चाहिए इसके पीछे का, सिर्फ जितना भी इंक्लूड मैथमेटिक्स होता है इस पर्टिकुलर टॉपिक में उतना ही सिर्फ लर्न करना है।
So that's what I'm telling you, that mathematics is discussed there.
अच्छा,
Yeah,
लेकिन कोर्स
introductory.
लेने
I'm
में
not saying
बहुत
you
टाइम
enter course. I said that you go through introductory tutorial, introductory class only.
हाँ
Not
ओके
enroll for entire course because there mathematics is explained nicely.
ओके मैम ओके। और आपकी तरफ से कोई मतलब ऐसी मतलब कोई भी वेबसाइट हो जिसमें लीनियर अलजेब्रा और उसके टॉपिक जो है वो अच्छी तरह से समझाए हो, मतलब
I
एज
need
अ
to.
रिटर्न
There is
स्टफ।
no fixed website. There is no one website or not one resource.
ओके ओके
Multiple resources are there. So just you need to search because nowadays now, if I have made this presentation 1 year back, then it becomes obsolete by 1 year because so many resources, new resources are produced by 1 year.
हाँ वो तो है। ओके
हाँ,
ओके थैंक
बहुत फास्ट डेवलपमेंट होता है ये सारे सब्जेक्ट्स में, तो बहुत नया नया आता है। Earlier we used to refer to textbooks, but now we do not refer to textbooks much. But for this topic, you can surely refer to textbook because ये सारे standard fundamental concepts है, तो वो textbook में है because ये पुराने concepts है. These are not new concepts, right? So for like traditional concepts, traditional topics, you can surely refer to textbook. There also they might have explained this new mathematics required for neural networks, and I'm sure it must be available in your library too because this is traditional topic, this is classical topic, this is not new. Single layer perceptron, multi-layer perceptron tutorials also, I'm sure you will find good tutorials. You can search for video in Google, single layer perceptron, multi-layer perceptron for in-depth understanding of mathematics. Why I do not provide, fixed resources? Because otherwise your knowledge would be limited And nowadays, limited knowledge is not sufficient. Earlier, we used to refer to only one textbook for our subject. We used to prepare for exam. We used to like reference book बोलो या textbook बोलो, वो सब एक ही होता था हमारे लिए. Because तब तो गूगल कुछ था नहीं, इतना ऑनलाइन इंफॉर्मेशन भी नहीं था, कभी भी नहीं था. राइट जब हम पढ़ते थे तो वी यूज टू रिफर टू ओनली वन टेक्स्ट बुक और हमारा नॉलेज बहुत लिमिटेड रहता था बिकॉज वी वर नॉट रिफरिंग टू मल्टीपल रिसोर्सेज फॉर वन टॉपिक और वन सब्जेक्ट. बट व्हेन यू रिफर टू मल्टीपल रिसोर्सेज यू विल गेट लाइक a lot of information related to that topic. From every corner you will get information और फिर आपका complete वो ऐसे मतलब मान सकते हो आपकी complete information मिलती है आपको gradually. So if I tell you today, okay, refer to Edureka, refer to towards data science, refer to Vidya Analytics, refer to machine learning mastery, then again you will refer to that only, right? But it's not necessary that that one web resource has discussed everything involved in that single layer perceptron or this neural network architecture. Maybe slightly more is available on, say, Edureka. A bit more or something different is available on, say, this towards data science also. So that's why I say that do not stick yourself to a single resource. And single resource को अगर stick होना है, then better you refer to textbook. तो इधर उधर ढूंढने की जरूरत ही नहीं है. And because this is classical topic, तो textbook में बहुत ही अच्छा दिया होगा. So you can also refer to textbook in that case. या फिर आप अच्छे से सर्च करो गूगल में, टेक्स्ट बुक में जाओ, वीडियोस में जाओ, व्हेन यू सर्च, एंड वीडियोस में बहुत अच्छे वीडियोस मिलते हैं. ओके, एनी अदर क्वेश्चन? Yeah, fine. It's 6 and today